Hello, everyone. Welcome to Amplifying F Sharp. This is the session for the second session of this month. We are very excited to have Peter from the F Sharp team, who is going to talk about compiler stuff and all about the reusable type check. But before we start with the session, I would like to do some housekeeping and talk a little bit about what is Amplifying F Sharp and why we're doing this. So Amplifying F Sharp is a open source initiative where we try to encourage and help people to contribute back to F Sharp. So as you can see, we have a website called amplifyingfsharp.io, and in here you can read all about us, why we're doing this, what's our incitation, and blog, and also some extra content that we have here, like F Sharp Essentials, where we teach the essential of F Sharp, and yeah. So if you are in the .NET ecosystem and you are interested in F Sharp and you are basically you're wondering how can I, help the F Sharp ecosystem, just send us uh, a request and basically submit a session so we can talk about what you're interested in. All you need to do is press join us, and we will basically need to know just a few details like your name, the company, your time zone, and the topic that you want to talk, so we can schedule the session based on your availability and our disposition as well. So yeah. So for today's session, we have our friend Peter from the F Sharp team. He has been a regular guest of Amplifying F Sharp, talking about tooling in the past, talking about compiler stuff. Yeah. So yeah, so he's going to talk today about data pickling in the compiler, and this is important. I mean, I'm not going to pretend that I know what data pickling is or this is part of the compilers, so I'm not going to try to explain that. But yeah, this is very important for having a good experience with tooling and in general with F Sharp. So yeah, we're really glad to have Peter with us. So without further ado, I will hand it over to Peter.
Okay, hello. Thanks for passing me the word. So I'll be talking about data pickling, a brief intro on why I'm talking about that. For a few months actually, I was doing a big rather big experiment in the F Sharp compiler. We had this idea to reduce type checking results between compilations. One application for it could be like a big testing project which has like 100 unrelated testing files, and you change one and you don't want to recompile the world, but you do now. That's how things work. .NET handles like the project in the sense that it will recompile the dependencies if it doesn't change, but like the actual thing, the actual project, it will recompile pretty much whatever changed there. So that's how things are. We thought there were like different attempts and different things on how to handle that. Like partially related to that was the graph node type checking mode. And that's like a sort of orthogonal idea to reuse the type check results so that like we can save them on disk and basically then use it on cache, restore them during like the next compilation, and get them for all the modules, all the things, whatever we call it, for haven't changed. So that was the idea. That was something I was tinkering with for a few months. I will get to that probably at the end of the session, but that feature, that experiment heavily relied on serialization, deserialization, and in F Sharp, that's called by those weird words, pickling and unpickling. That's not only a Sharp thing. I was looking to that back in the day. So that's kind of joke terminology in programming communities. So like that applies there. But I still think that's very unfortunate name because it's very confusing. Like every programmer has more or less like dealt with some sort of serialization, and just having different words for that in F sharp is weird. But like nobody will want to change it because like hey, it's funny. So that's like the main thing I actually want to emphasize, that those pickling and unpickling are pretty much fancy words, or not that fancy, but other words for serialization, deserialization that we have. And I was doing a lot of work there in the part of the compiler that does that. And I just realized there is, well, I spent like a few weeks trying just to understand what the hell is going on there. John Simon was doing some sessions on explaining compiler intrinsics, compiler internals back in the day, and they are still to big extent very applicable and relatable these days. But I haven't found anything about like this particular thing. And even internally in our team, like picking the code that does that actually brings a lot of horror. People are afraid to mention that, and whenever somebody mentions that they want to fix something in pickling, everybody else is scared because like it's just very scary in code. So yeah, I thought, okay, I will just do something very simple here, as in like debug some um compile something very similar and like look into the pickling code, like kind of explain what's happening there now as I have somewhat more insight, and that can be used later for some reference, because again, I don't expect this to changing anything. Things are so brittle that I don't think people will be like courageous enough. So I hope this will be applicable for some time. um, that's for the intro. I will share my screen, and right, there you go. Yeah, and that we'll just have this small debugger session. I actually want this to be sort of workshop interactive thing, so that whenever something is unclear, feel free to ask away right away, because I'm already a bit tunnel vision since I was working with that and got used to the pain, but like it doesn't have to be there. So feel free to stop me and point to particular places. I have the latest main here. I haven't done anything but that fact that I added the new file to the component tests called amplifying of sharp tests. And I'll just create something so that we can debug the code. I'll create a library and a main program that uses it, and that's it. That's how all the tests pretty much look like in that project. So yeah, that will be pickling test. I like live coding. That's why I'm doing this. Let's have the library. We'll call it the library. And okay, some code. Yeah, it will be something very simple. We can have the module and some function, right? Uh, Good enough. Yeah, compile it as library. We have in the component test, if somebody hasn't worked with them yet, there are like all sorts of auxiliary functions to make things a bit better. Compile libraries, executables, name them whatever, run them, and so on. So there is pretty much good infrastructure there. We'll have the program thing here. Yeah, I don't have that much imagination here today for the naming. And the program will use the library. So we'll use the multiply function. And that's it, I think. That's good enough. Let's add the reference to the library. And let's have it as a program. So that should be good enough. So now all we need to do is compile it. I think that's pretty much it. So that will be set up. I actually don't expect writing much more code today. I will be debugging all the code all the time. So that's it. That's the good setup, I think. Yeah, see, now it's compiling all the tasks because it's just like modified one. And like one of the reasons we want to do the feature is to actually deal better with our component tests because there are like so many of them. We should split them one day anyway. What we'll be looking at is is the heart of the compiler. That's where things happen. The FSC, FS. There were a lot of talks about compiler itself. So you might know the structure. Oh, okay. So yeah, okay. So we'll get to the compiler and we'll see where the serialization is happening. Compiler has like what, 6 phases. We'll end up here sooner or later. Yeah, so the framework is creating pretty much all the stuff in memory, then writing the task project to the output folder, and that's it. We have like the framework doing that for us. There are 6 stages in the compiler. Different things are happening that should also be refactored one day. But the first stage phase is where like the type checking is happening. That's interesting, but not for today, pretty much. What we need is this phase, which is happening in the third phase, encoding signature data, encoding optimization data. Yeah, that's again another unfortunate synonym because like encoding, serializing, and pickling up to a big extent same things, different names for the same things, but like that's life. And yeah, so we have the compilation unit, the CCU. Let me see in the debugger. And that's what we want to remember. Somehow we want to record the information about it because we'll use it in the main program. So that's the reference library. We'll need to use it somehow. So and I mean it's trivial. So we have like the module, we have the entity. It has what value, one value. It should be somewhere. We'll get to that. So yeah, let's dive into this encode signature data method. This deals with two resources. It doesn't really, well, honestly, I don't really know the reasons why there are like two resources. I think that's somehow related to backward compatibility. That's kind of a detail here. So there is this, we are now in compiler imports. So which is a bit unfortunate name because it's not only about imports, but also about exports. We're now exporting the data. We are getting to, yeah, historical reasons, a lot of historical reasons here. That's just name of the files on disk or within parts of the assembly. That doesn't matter that much. The heart of the method, the heart of the write signature data method is pickle to resource call. That's where pickling comes into play. And until here, the code looks like, something following some naming conventions. And here in it kind of soon we'll get out of that sort of. Now we'll get to type treat pickle file, and that's a huge file where all the voodoo about data, pretty much all the voodoo about data serialization is happening. So, and the top method of it is this pickle obj with dangling CCUs. Could be named better, but that's how it is. What we're doing here, we are having the state, and actually two states. We are writing things from the state to the state. And again, I don't really know why, but that doesn't matter that much. So we will mention a few weird acronyms here. They are not, I think they're not even documented. I had to ask people around about like what this means. OS means output stream here, because we are exporting things. Export is associated with output. So output stream, that should be written properly. But basically all the O prefix here means output entities, output values, output anonymous infos, whatever. So we will work with that state. So there will be a lot of mutability here, unfortunately. So, and this small method call is actually starts doing the whole serialization. P is for pickling. We have the main top thing to pickle, which is the entity. Pretty much here it is, entity of the library with the values. And we should record the information about that on disk. Some information that we need. I'll get to that later, that it will be not all of it, but kind of most important bits. In the module or namespace type, we can actually see all the like kind of valuable pieces of information that we have here. And somewhere here, somewhere here there should be actual values for um, actual members and logical names and ranges and all this kind of stuff. Yeah, there it is. Multiple, that's the name of the method that we have. And further details here like parameters and so on, like argument should be also somewhere there, x and y. So it starts with this weird um, weird shortcut, which is called the tuple of four. So those are very, in my opinion, redundant things. We didn't have to have them. That just further complicates things. But what it means, I mean, I don't understand why it's there. It doesn't save pretty much space, to be honest. But what it means, and it complicates the debugging. So that's equivalent to writing use this module or like use this function for the first argument in the tuple, use second function for the second argument in the tuple, and use third thing for the third argument in the tuple, and force to do nothing in that. Wait, this is forced thing because space applied to nothing. So, and all this should involve the space or the state, sorry. So that's, we could have just like 4 function calls there because they are all like void. They're not, don't return anything. They just like pickle on disk. And that's how it should have been done, but that's not how it is. So, and it goes like that. So it goes, first will be this method called. We are here now, and we will pickle everything that we will serialize, everything that we want to serialize about the entity. One more weird acronym here is this OSGN. I think it stands for output stream graph nodes. So, and note that some methods here have this, I don't remember how I call it, but like it doesn't use the camel case. It uses camel casing in some on some occasions. On other, it uses this like underscores. In other places, it just like writes things without any delimiter. So all lowercase. It's horrible. I made it at least a bit better by applying Fantomas to that like a few weeks ago. Before it was excluded from Fantomas, I thought that's too bad. Like let's at least format this. So that's a bit better than it used to be, but still there are like a lot of things to improve here. So we'll eventually appear in this pickle entity spec data method. I just want to mention that a lot of information is repeated, a lot of entities, a lot of data strings we might have in the assembly, like same strings, and there are like caching mechanisms. We'll see if I get to them. But basically for those reasons, we have those dictionary tables, whatever we call them, which we use for saving duplicate information to save space on disk in a way. So the actual, hang on, thickening is nearly there. That's not important yet. Yeah, so here we have this entity that I showed back in the day, a few minutes ago, the library, and we are writing different information about that. So we don't have a lot of things. But for example, we have the logical name. And let's just dive into one thing here, like pickle string method. So again, it does some kind of encoding here for caching purposes. And that's at least all can be sort of debuggable. So it looks like, hey, have we already met the library string, this just sequence of characters? And no, we haven't. So we are adding them to the table. And having the basically dictionary value for this. So we encode that, and then we write this byte pretty much to the resource. So we now have the value 0 as the first string that we encountered, and we'll eventually just get to bytes on disk. And there is like a lot of optimizations here and things and byte arithmetics, which I don't entirely even understand. And like all those things that you study in the like first grade of the university. So, but that's kind of, you see, module bits. That's where it gets kind of very low level as much as it can get. It just saves bytes for now in the memory, but like we will get to where it's actually located in the assembly. So there are different associated mechanisms here. What's interesting or what kind of happens meanwhile is that we have this state, ST is for state, and it keeps the buffer of bytes. It keeps where we are in the buffer. So that's basically a byte array in a way. So, and we will be moving through that over and over. So we have just now saved the string, the library string to the disk. Different things are saved in different ways. So some are cached and coded and whatever, but like for example, there are mechanisms for caching options and discriminated unions, and that's working in the way that we need to we do the tagging. So if that's none in that case, we save 0, and if it's something, then we save 1. And then once doing the deserialization, we'll first get the tag, and then depending on the tag, we'll understand what we are actually decoding. So that's how it works with options. With unions, it works like in the same idea, just like first saves the tag, and then like then actually does the actual encoding. So we don't have any value here, but we need to mark this. We need to mark that like that's none, and so on. So it eventually all here gets to primitives, gets to numbers, gets to integers, and then to bytes. So everything, because it's memory, it's physical space, it gets there. So access. With the list, it also lists in other collections. Yeah, we don't have anything here. It first saves the length of the list, and then actually does for all the elements of the list the serialization algorithms. So, and that's again for the same idea, so that we know how many times to apply the deserialization algorithms later, and also like for checking purposes and so on. So they're more or less, once that's like you get this in your mind that it gets to the bytes sooner or later, that's the main idea here. There are different hacks and weird algorithms included here, but the idea is to just write the byte stream. See, as we are writing things on to the byte array, we are incrementing the marker. So I don't know anything interesting here. Yeah, like that's what I was mentioning here, like with the how we cache, how we serialize the discriminated unions or enumerations and whatever. So we might get into some cases of interesting mechanisms here later. For now, I just wanted to show that eventually all those helper functions, they are some kind of algorithms on top of writing bytes to disk, to the stream in that case. It's not writing disk just yet. Eventually we get this stream. And we also save some auxiliary information to the state. So for example, how many entities we have, and some other things that we want to cache, for example. So how many values, anonymous infos, and so on. So that will be again important when like deserializing the things. Then for some reason, as I say, I haven't looked into that, why it's happening, but like we pretty much rewrite things from one stream to another stream. That doesn't matter that much. Probably it's a good question. I didn't look into that. And eventually we do some checking here. We save all the sizes for the things that we cache. Arrays of things that we cache. We also write them actually in the beginning of the resource. And that's kind of it. We have this stream of bytes. And we return it here. So it's what? It's 457 bytes of information, even for this trivial like one function module. So the more information, the bigger resource gets apparently. So then we write it on disk. We'll get to that. It's still some manipulation with resources yet. And names, they have, yeah, signature compressed data, the library. That's just good thing to remember for now, that the names for the resources. And that's it. So that goes to the assembly. And let me show you where it actually sits later. Let me just find the output directory for this. Oh no, sorry. I'll rerun the test. Didn't stop it at the right moment.
When that is running, Peter, I have a question.
Sure.
So, this deserializing, it's not only for F-sharp code to F-sharp code, right? Consuming libraries, it is for anything .NET. Can be
Yes.
you're consuming, for example, some library from DB.NET or from like C Sharp, and the same, we record or we serialize all of the classes or like code that comes from that C Sharp library, right?
Yes, exactly. All the references that we have, which is whatever .NET really. So yes, I mean we'll soon be deserializing, so you'll see that actually happening there. I'm just trying to find source files where we are. Yeah, so that's the folder where everything's happening, and we will soon get the yeah, we have the library here, and if we open it with some kind of deserialization voodoo program like ILSpy, um, then you'll see. Let me remove everything, all the old stuff here. Then you'll see that besides the deserialized information that we have like from IL, which is basically the code of of the project, we have the resources here, and that those are the resources that we saw during the pickling. So, and those are really just arrays of bytes. Notably, the bytes are there are somewhat fewer bytes than we have after doing the pickling, and that's because we are applying the compressing algorithm somewhere. Let me see if I can quickly find it. So that was main3 function. And okay. Yeah, same happens for the optimization data, by the way, that we won't dive into. Doesn't really matter what data we actually serialize. I was trying to, when doing like my experiment, I was um, trying to pickle and unpickle even some other data. I'll get to that at the end. Yeah, so we have this flag, compressed metadata, which is on by default. And when we get this array of bytes, it's about 400 bytes. And after using some smart algorithms, we get fewer of them. That's something I was reading about that. That's using some .NET primitives, or not primitives, but basic .NET functionality to deflate stream, and it uses some algorithms for compressing bytes, which is popular and described in Wikipedia. So that's nothing specific there. But you can, if you want to match the actual thing to the code, because yeah, you can just save the resource on disk and read the bytes if you want. You can apply the flag which is called um, something like compress. Uh, yeah, you can. There is this option compress metadata in the F# compiler option, so you can just pass the flag compress metadata minus, and that will not do this deflating. This will save the bytes as you see them during the pickling and so on. So let me just get to the unpickling stage. So I guess that will be somewhat shorter because in a way that's the opposite as you would expect. And if modifying anything in the pickling logic, you should be careful in adding like the opposite part of it to uh, to the right place. So because if you pickle something earlier and unpickle it later in the order, you will get like other memory. Most probably things will explode because like compiler will try to somehow use things for compilation and it will like explode there. You'll notice it. So it's just important to keep the order here. So we are compiling the first library. So we're doing the pickling at the end in the main 3 stage. Let me just, yeah. And now we are, yeah, here's happening. Now we get the second time to the compiler. That means that we compile now the actual program. And we need to get the resources, the reference. And I think it happens in the main 2 stage. Can check it here. Compile imports get signature data is used in prepare to import reference F# assembly, and that's used in try register. Yeah, okay. So I guess it we need to hang on. We'll get here and I will show you from where. So that's, I think it's happening actually in the beginning. Yes, it's happening still in the first phase. We are resolving assembling. Yeah, we are importing the assemblies, and that's where we also do the unpickling eventually. So it's somewhere here at the end before we do the actual parsing of the source that we have on hands. So as you see here, we are first dealing with the F# core because we implicitly use F# core in every program, F# program. And that's also an assembly that's added during the compilation, and we need to get the information from the assembly. So first we are actually dealing with that thing. And it can be like any other, as I said, like any other .NET thing pretty much. So, but then second thing that we will be importing is this library. And we are getting to the get signature data function and getting to the resource in the assembly, and then pretty much doing the opposite thing that we have done before in pickling. So, and that has now different state. Now it's the input state because we're importing things, and all the things here are prefixed with I, which stands for input, input stream, and so on. So, and we are initializing the state and then updating it pretty much. So we get the first we encoded the names of the CCUs, compiler units that we have in hands, which is already the F# core, which was used like in the library, and now the library itself. So, and then we are getting all the information that we serialized. So we need to first get all the cached tables pretty much because we'll use them in the actual unpickling of the assembly. So, and that's coming soon. Where was it? Where was you called? Yeah, okay. Data here it will be. Yeah, it's very important things are called with just like one letter. It's a bit inconvenient, but that's kind of life. So by now we have all the auxiliary information on hand. We have all the cached information, the number of values, type parameters, and whatever we cached there. String table we have all the 13 strings that we somehow met during pickling, and it makes sense, like names of the parameters and assemblies and whatever you want. So, and then we dive into actual unpickling. It again uses these like weird primitive functions. It can go actually crazy. I think it has like u tuple 17. That's like that's how bad it can be. So but eventually it does get information from the disk and creates all the F# data structures on top of it. So all the types it creates from the raw bytes, then raw strings, integers, and whatever, it gradually creates the universe on top of the bytes that we have. So we get to the entity. A lot of information that we might not have all the information that we have, and therefore some things in the data structures that we build, they are not initialized, and that can like explode. But that means that it's not needed yet for any practical reason in the compiler. So that's kind of the idea there. So it's, yeah, I was showing how the unpickling of strings works. So, and it's happening here the same way. We get the place in the table, in dictionary, whatever, and just find the right string in the table of strings that we have somewhere in the state in input strings. So that's it, and so on and so forth. Eventually we create the CCU info thing, and we have this pickled CCU information with all the data that we need. As I say, a lot of things here throw. So, but as practice shows, some things are very hard to pickle because like a lot of things reference each other, and you could run into all sorts of Stack Overflows. So it's also for practical reasons we don't pickle everything that we can, but only what we need, and everything else just potentially explodes. So in the best case scenario, in the worst case scenario, it's initialized to default, and that can be confusing. So, but that's kind of how it is. I'll just find kind of important or semantically meaningful bits in what we have deserialized. It's module or namespace types. So we have all entities here, the module, and this should also have especially IL details are often not initialized to anything. But so yeah, and eventually we have our important information that we use in the program that we have at hand. So, and that includes like names of the parameters and so on, and ranges where it's used, and so on and so forth. And again, some things are just not not here or initialized to default nulls and whatever. So that might be inconvenient. So we get all the data, and then we use it later in the compilation pretty much. So that's a different topic what we do with that data, but we use it like pretty much everywhere in the later phases of the compiler. So I think that's the most important bits. I will just quickly show the structure. Yeah, now we have the imports, now we have the assemblies. I'll just quickly show the structure of the type tree pickle thing. It had some structure at some point, let's put it this way. It doesn't hold really, but I think in the beginning it was a reasonable piece of coding, and later it became a bit chaotic. So here there are those states that we have with tables and so on, and different primitives we use for that. Then there are, yeah, those are all primitives for that build on top of each other. They are not recursive, they just build on top of each other. Then there are those pickle tuple things, and then unfortunately that gets mixed with the unpickling code. So, but the logic here is that it now also goes through primitives, and at the end, after we have all the primitives, we start working with simple data structures like arrays. And on top of that, we start actually somewhere we will be doing the actual data types, pickling, serialization, whatever, like IL array shape, IL type. And somewhere it starts becoming recursive because things reference each other. And yeah, that's all like a recursive piece of thing here. And same for unpicking pretty much. I think that's kind of it for the main part of what I wanted to say is, and the way I also work with this today, it's how you can investigate. So we don't have any unit tests for pickling itself, which is very unfortunate. That's really a bummer, because this is very brittle thing. and and a lot of things are happening there at the same time. But like in that case, integration test level, you can sort of get there and see what's happening for different pieces of code and so on. So kind of that's how you can debug, investigate, fix, and so on. Uh, I think that's it for the main part of it. I've been talking for about an hour, so I probably will take some questions if you have any.
Yeah. Thank you, Peter. This is one of the parts I haven't really touched in my compiler journey, and I think it kind of shows the light for me in couple of scenarios. For example, I was trying to solve a problem a couple of months ago where, like, for some reason, when I was reading a C# library, I was reading some classes that had some derived classes and all of that. And at some point, the information was lost from the C# project to the F# project. And I think my suspicion now is that this pickling and the pickling part, I think is not actually pickling the that information, like the derived the right classes from a that is using that a class that is using multiple levels or nested levels of the
Yeah,
right. So that might be something I can look into and see where in the pickling are we actually reading the type information, the information of the types from C# and actually making sure that I'm looking into the the derived classes that might have attributes, they might have something that is not being passed through the metadata.
yeah,
Because then when I get to the type checking or when I get to the check declaration or check expression, the information is gone, is missing. I mean, it went, it didn't went through from C# to F#. So yeah, that's been very helpful to me. Um, yeah. So
sure, sure. It might be there, it might be not there, but that's sounds like a potential culprit in your case.
yeah, cool. Let me check YouTube to see if we have any question there. Check. Yeah, I don't see any question. Is any question here in the chat? Um, all good.
Okay. Nice.
I mean, it's a very dense, part of the compiler. It's like, it took you like, like some time to actually, understand all of that. So I think this is very useful for, reference point, I think.
Yeah,
Uh,
that's what I hope it will be good for, because as I say, I was doing my feature and like first week for sure I was just doing this what I'm saying, just like I created a simple thing and was like going through that, trying to understand what's happening, where we get like all the bytes and so on. So that's so that I just get into that context.
but the idea was also to use this, they use the serializing and serializing to be able to cache the type check,
Yeah.
right? So,
Yes, I I actually wanted to say a few words about the state of the things there. So I pushed a few weeks ago, or I pushed the PR with the proof of concept. So in my opinion, this is a proof of concept that's a viable idea. So I managed to use some things to make it work for some things, for like kind of trivial pieces of code like I showed today. Get all the cache all the type information and get it back. So that's that worked. And as I say, since I was touching the pickling code, I first I was just like messing around, but eventually, since it was a lot of new code, I just added new uh, new file with pickling logic. Let me find its type check results, and it's also huge. It's just like 2,000 lines of code doing just this on top of the primitives that we have. So let GitHub render this. Okay. Um, yeah, that's all the same type of code really. Um, I'll try to find the top points of it, which should be, yeah, somewhere at the top. Yeah, that's unpickling the state, the DC state, and actual checked implementation file data. So all the stuff that we use in type checking in the first phase, and like partially in the optimization phase. So, and that's just a lot of things, a lot of stuff with the entities. So for now, pretty much all things that we have the entity, but we save the name of it and just some edges of it in a way. But for the type checking, we need much more information about entity. And it's damn hard to do that because that's a lot of memory, that's a lot of stuff, and entities reference each other all the time in all the places. So it's hard to come up with the way to um, do something generic, but also which would not consume like 100 megabytes of memory and will not run into Stack Overflows, because that's something I was doing. I was facing like all the time. I was just getting into Stack Overflows because of reference entities reference each other everywhere, from like attributes to the like argument names and so on. So that was a bit unpleasant, but the the logic is the point is that it's really eventually just more writing on disk and from disk, and everything else here in this PR is sort of ceremonial around that. I made it working for, yeah, some simple things, and I made it working even for multiple files for trivial cases again. So, and with disabled optimizations, because optimizations, some of them need even more data. So that kind of worked. So, but only simple cases. So doing anything generic, that's, as I say, that would need much more effort, and we wanted to time box it, sort of. Honestly, I'm not sure when we will be able to get to that. I want to keep this in the like state which it can be, whoever can jump on that and continue working. And for that, I guess I should at least fix the latest merge conflicts, which happened happened. I think so. Yes. So I will do that. I wrote a bunch of commands, pretty much me being sad about how bad things are. So, and here in to-dos, I also mentioned the main obstacles right now. So, or like the main things that we need to address. For example, yeah, with states, we need to save the state of the compilation of the type checking, between the files, we have pretty much for every input, we have the state of the compilation after checking the input. And those states will have a lot in common. So, and we should have some algorithms for having like deltas of the information that we want to save. And that's all separate topic that should be done there. Also, yeah, I mean, I won't go into details because that's what that PR is for. So generally, as I say, I'll try to at least maintain its shape somewhat. And it definitely wants some kind of fresh take in a way, because I was doing it for a few months and I was getting frustrated, furious, and there's like nobody to ask really. So that's kind of experiment. And it's doing that, I was pretty much on my own with that. So trying to understand how things work, if they even are possible, and so on. And eventually you'd get like tunnel vision of working pretty much the whole day in one file, in this like pickling file, and that's unhealthy for for you in the long run. So therefore, I think it should have some like fresh take, either by us in the team in the future, or by whoever wants to deal with that. So the potential here is very big. It's just a major engineering challenge. I'd put it this way.
They always say that caching is one of the, topics that is hard, naming, caching and off by one error. So
Yes, that's exactly it. It's like, and both happen here. It's like caching, like the first error, and like the first problem, and naming is horrible there. So if anything, I would at least like rename some things there so that they follow some kind of like convention. So that was my second step after applying Fantomas to this.
yeah, I think it's also like in order to understand how bad is something, first you need to basically give it a try and see, come
Yeah.
up with a analysis and kind of identify the pain points, and then another work can be done on top of that. I had another question, which is, this feature was using some optimizations that already were contributed by, I think, external companies like graph-based checking, parallel optimizations, and like parallel IL XGen. Do you think those will it make it to the, let's say, to the stable and can be enabled by default in the compiler, or is it that these they won't really be usable?
So first of all, this feature is partially related. So it's not entirely the same topic, but like I would like if getting further with that, then you need information. Eventually, you need information about what things you want to um, recheck. So you need the mechanism to understand what parts of how much data you want to restore and update in the type checking state. So you need to understand what files have changed actually between the compilations. And that's where, for example, that's where graph node type checking would come into play, because part of it has this algorithms of detecting, of working with dependencies and figuring out what has changed. So the plan was to actually apply this there. So as for the general state of the base type graph based type checking, from what I remember, we had consensus in the team that get in and get public, and it got to preview. I think it's in preview now. So I think we just need to make a push and enable it like by default. So there are no like principal objections to that. So they're just general I'd say a lot of things are happening in the team. I can go to that like once once we are uh, offline. So, but generally, the vision is there that we have that we want this to work by default.
Yeah, that's good to know. Thank you. Yeah, I don't have any other questions, so no question on YouTube and yeah, chat's also okay. So yeah, with just going to say again, thank you, Peter, for taking the time. It was a very insightful session. A lot of new concepts, new words, new naming around, and I think it definitely for people like that are involved into compiler contributions and want to know a little bit more about what those files are doing in the compiler, because I haven't really never touch the fsc.fs file. I don't know exactly what they do. Now I know. Now I have a resource where what I can use in the future to come back to this session. I understand what's going on. So yeah,
Sure, you're welcome.
yeah. So thank you everyone who is watching in YouTube. Thank you everyone who is in this some call. Please, if you want to know or you know something about the library in F Sharp, or you want to, or you have a contribution, you are, in the middle of finishing it and you are blocked and you don't know how to continue, send us a request on submit a session on amplifying F Sharp, and we will try to schedule a session. And yeah, thank you everyone, and have a nice weekend.